All right, thank you for joining and welcome to our webinar on how to code faster, write cleaner using AI coding assistants and Sonar. I'm Kirti Joshi. I'm your host and moderator for today's webinar, which will be presented by Manish Kapur and Jeff Zapatashny. Manish leads the product marketing technical team here at Sonar Source, and Jeff Zapatoshny leads our solutions engineering at the company. So before we get started, I'm just going to spend a minute or so over some housekeeping items. This is a 45-minute session that includes Q&A. Throughout the session, you can submit your questions in the Zoom Q&A box, not the chat box, but the Zoom Q&A box. And we have two panelists joining us today, Lucas, who is from the solutions engineering team, and Robert, who is from the product marketing team. They will answer your questions as they come in the Q&A box, and they'll leave some for me during the webinar to ask them live to Manish and Jeff. This session is also going to be recorded, and at the end of it, we will send out a link via email in the upcoming days. And so finally, at the end of the webinar, we will present to you a short survey on the screen. Thanks in advance for your participation. Do tell us what you liked, what we should improve, and what other topics you would like to see us cover in future webinars. All right, so without any further delay, I'd like to introduce you to today's presenter, Manish Kapur. And Manish, I'll let you take it from here.
All right. Thank you, Kirti. And hello, everyone. Thank you for joining the webinar today. Can anyone guess why I have this picture of a group of happy people on the screen? Of course, it's an AI-generated image because it's an AI webinar today, so it's an AI-generated image. But why is the picture being shown here? All right, so today is March 20th, and it is celebrated as the International Happiness Day. It is a day to be happy, of course. And I'll start my webinar today by wishing you all a happy International Happiness Day. A fact that you may not know, this day was started or initiated by Bhutan, a country in Asia, which actually prioritizes national happiness over national income. Amazing, isn't it? All right, let's get started with the webinar. The agenda for today's webinar is shown on the slide. We'll start with an introduction to generative AI code generation. We'll talk about the benefits of generative AI code generation. We'll talk about risks and challenges. Next, we'll talk about how Sonar can help make AI code better. You can code faster with AI, and Sonar can help you write cleaner code. We'll talk about that. Jeff will be doing a live demo of the entire workflow, starting from developing the code to using the AI coding assistants, and to make sure that the code developed is reviewed for code quality and security. And then finally, we'll wrap it up with some additional resources for you. All right, let's get started with the introduction part. I will start by talking about the AI landscape to set the context for this presentation. So let's start with artificial intelligence. Artificial intelligence is a very broad field. It's a broad term. It's all about simulating human-like intelligence using machines and computers to perform tasks that typically require human-like reasoning and decision-making. A couple of examples that you may be familiar with on a day-to-day basis is Amazon Alexa and Apple Siri. These two applications, they use natural language processing and machine learning algorithms to understand the user queries and provide assistance or responses to you. So this is one of the most common example which everyone can relate to when it comes to AI. Next, let's talk about machine learning. Machine learning is actually a subfield of artificial intelligence, and it is all about training computers to learn and improve from data. So what can be an example of machine learning? most of you would have used Netflix or Spotify. Netflix and Spotify applications, they use something called recommendation systems, which are based on machine learning. These systems actually analyze the user preferences and behavior to suggest movies, TVs, and shows and songs, etc. They've continuously refined their recommendations based on user interactions and feedback. So they learn from the data, they learn from your behavior, they learn from your interactions. So that's machine learning, right? Let's get deeper into it. The next part of the layer, if I may say that, is deep learning. Deep learning is a subfield of machine learning, which actually uses neural networks to learn about intricate patterns. So what would an example of deep learning in action be? The one I can think of is facial recognition systems that you see at airports and things like that. Facial recognition systems, they use deep learning to learn about the intricate patterns on human faces and recognize the people in the picture. And the next, we will talk about large language models and generative AI. And that's the crux of the topics today, right? It's all related to AI code generation. So what are LLMs and what is generative AI? LLMs are advanced machine learning models that are trained on a large amount of text data. And using this data, they can comprehend, generate, and manipulate human language. And what is Gen AI? Gen AI is basically the ability of large language models or LLMs to generate novel content using the deep neural networks. A common example, which most of you have used, is ChatGPT, right? It's an example of an LLM in action. It uses generative AI. So now that we have a understanding of the AI landscape, let's talk about specifically about Gen AI and LLMs, right? So Gen AI is basically has got several applications. You can produce various types of data using generative AI, such as text, audio, images, videos, even synthetic data. This whole, generative AI technology has opened up a whole number of use cases and applications in the market. Everyone is talking about generative AI today. Everyone is talking about LLMs and the wide range of applications that these can support. Some of the key applications that generative AI and large language models support are shown on the slide. Things like anomaly detection, language translation are some of the use cases, right? Today, however, we'll focus on the use case of code generation, how generative AI is used for writing code, creating code for you, right? It is the ability of LLMs to assist you in code creation, producing code snippets, or sometimes entire programs itself. All right. We will start with a poll here. Can everyone take about 30 seconds to respond to this poll? How often do you use AI code generation tools today? All right, the answers are coming in, and occasionally seems to be winning as of now, but we have responses for we have choices. Everyone has responded to all the 4 choices here. All right. So as you can see from the results, we have several folks who responded, and thanks for participating in the survey, in this poll. Occasionally is where most of you are. About 45% of you use it occasionally, and about 23% of you are using it frequently. And I'm not surprised by these results. This is generally what we have been seeing at Sonar in terms of our user base as well. Some are exploring the generative AI tools, some are actually frequently using it, and some are just never have used them, but are looking into it and thinking about using them. There are very few who are always using it too, so which is good, which is excellent, right? So we have a whole range of folks participating in the survey, and it gives a good feel to us as to where you all are coming from. All right, so let's get started with the presentation. So I will start with some basics, and then we'll get deeper into the actual demo and things like that, and how Sonar helps. So what is AI code generation? Let's set some basic concepts and put some basic concepts in place. AI code generation, as I mentioned earlier, leverages LLMs to write code based on your intent and based on your inputs. LLMs are trained on massive data sets of code. So there are specialized LLMs which are trained only on code. There's LLMs like which are trained on both text and code. So you have several LLMs that are out there, and these are trained on code. They learn how to recognize the code patterns and relationships in the code structure. And then using neural networks, they are able to generate relevant code based on your intent and based on your input, or based on what you're doing inside when you're using them. So typically, most of the customers that I have seen today, they are using code generation tools for automating repetitive tasks and generating some skeletal code and getting a jump start to start the development work. So there are three types of uh, code generation tools. Three, I'm calling it types. It's basically three ways of using AI generation tools. First one is IDE based, and that is, I think most of you would have heard about, who are using generative AI for coding. They would have heard about GitHub Copilot. So these are basically tools that live inside the integrated development environment, inside your editors, code editors such as VS Code or IntelliJ, and help you write code as you are prompting them with inputs, right? So this is typically used by developers who want an uninterrupted workflow. They want to start and use work with the tool right where they're writing the code, right inside their development environment, inside the editor. The second one is web interface based use of coding assistants. So here what happens and web interface example is ChatGPT. So you have a web interface, you ask ChatGPT, hey, write me a Java code for doing XYZ, converting temperature to from Celsius to Fahrenheit, something like that. And ChatGPT responds to you with a Java code sample. This is how you do it. So these are web-based interface. These are typically useful for people who want occasional code generation. They want to explore the tools, or they want to try something new, or they want to access the code generation capabilities from the browser itself without doing any serious work inside the IDs or inside the development environment. Next one is command line based tools. These, as the name says, they are using a command line interface. And example of this is Copilot CLI. Copilot has a GitHub Copilot has a CLI that you can use to write, do code generation and integrate into complex workflows. And the last one is based on using API. API based ones are like if you use OpenAI Codex API for writing code, and this is typically used for integrating code generation into complex workflows requiring advanced features. I have not seen many people use the API based one, but most of the folks are using the IDE based code generators. All right, so I'll pause here, and here's a second poll for you. So among the ones who have been using code generation tools, which of the tools are you using today? All right, the answers have started coming in. Thanks for participating. All right, so here are the results. It looks like ChatGPT is the most frequently used tool among the people who are attending this webinar. 51% of you are using ChatGPT to help you write code, which is not surprising. ChatGPT is one of the earlier LLMs that has been around. Copilot is the next one, which was also early to the market. So I would have imagined that most of you are using GitHub Copilot and ChatGPT for writing your code. And there are some who are using Amazon Code Whisperer or Tab9 or other tools which we have not talked about here. So thanks again for participating in this survey. All right, so the folks who answered that, they are not using any, or there might be some folks who are not using any tools today. You're not alone. There are some folks who do not use AI code generation tools, and that is perfectly fine. I personally think overuse of AI code generation tool leads to some reduction in critical thinking skills, right? So it's perfectly fine if you don't want to take that path right now and just watch the things play out. So let's talk about AI coding assistants. There are several of them in the market. There's a whole bunch of them. And what I have shown here on the slide are just a handful of them, which I have come across frequently being used and talked about. The commonly used tools in Copilot for ChatGPT, Google's AI code generation tools like Duet AI or Google Gemini. There is Code Llama from Meta, which is an open source code generation model. And then there's Tab9. All of these intelligent assistants help you at your code in real time and suggestion to write complete code or give you help in snippets where you need help. So here's a slide comparing those coding assistants. The idea here is to help you decide on which coding assistant to be used for your coding for your needs. So whether it integrates with IDE, the accuracy of the code generation capabilities of the tool that you choose, the features that that tool supports, the pricing and availability. And of course, you also need to look at the performance of those tools that you're using. So there's a whole bunch of things that you can evaluate to figure out which ones you want to use. So here we'll talk about GitHub Copilot Assistant for a brief moment, but this whole presentation can apply to any of the tools, irrespective of whether you're using GitHub Copilot or you're using not ChatGPT, actually ChatGPT to any of the coding tools. If you're using, the presentation will apply to all of them, right? But just for the sake of example, I'll quickly talk about GitHub Copilot. GitHub Copilot is basically a cloud-based AI coding tool, and that's what we'll show in the demo today. Jeff will talk about it. He'll show the demo. It takes natural language prompts and converts it into code for you, even completes some functions for you, or writes entire lines of code for you. It supports several languages, and it is integrated into the IDE and your development environment, and it supports multiple IDEs. And that is mostly the case with most of the IDE-based coding tools. So what are the benefits that customers get? I'm quoting two polls here, two surveys here, one from GitHub and one from another company called Aquilon. And the results from these two surveys clearly show that 46% of the code is already being written by the folks who are using Copilot. It helps them write the code 55% faster. And then there is developers using it for various things like writing complete functions or even writing unit test for the code that they're developing, right? So we can already see the adoption and benefits that coding assistants are providing. To recap what benefits AI coding assistants provide, there are 4 or 5 of them, right? It helps you increase your development velocity. It helps you with your productivity and improves happiness. And today is International Happiness Day. So what a coincidence. It helps you auto-generate code, auto-complete code, and helps with creative problem thinking and things like that. And all this translates to basically faster time to market for any software that you're building, right? And the last one is important, but you need to be careful about it, right? It makes coding accessible for developers and even non-developers. Technology has to be used responsibly. So we have lots and lots of benefits for AI from AI coding assistants. So what will happen if everyone starts using these coding assistants to generate code? Of course, the volume and velocity of code that will be generated will increase exponentially. And this is where we need to be careful about. When you have large code being produced at a rapid rate, you need to think about what are the challenges or risks that might be that you might have to think about when you adopt these technologies, right? So let's talk about some of the risks. Before I talk about the risks, here's another poll for you. And this is probably my last poll, and then there is one poll towards the end of the webinar. So if you can, again, participate in this poll, what is your biggest concern regarding using AI coding assistants? All right, folks have started responding. All right. So most of you have responded that all these are valid concerns, and absolutely, these are all valid concerns. Some of you might be more worried about code quality and maintainability, and that's fine. But in general, coding assistants have concerns about all of these things, whether it's code quality or technical debt or understanding the AI generated code. So just to summarize or talk about the four key things that you should be aware of when adopting code generation. These are some of the challenges that everyone should be aware of, right? The, while they give you a lot of speed, they let you jumpstart development, they accelerate the velocity of development. You also need to definitely think about uh, code quality. So there are four things that you need to look into, right? And before I talk about those two things, none of the tools that I've looked at today are capable of generating production level code that we need for any mission critical business. The code that AI tools are generating are basically the AI is trained on human developed code. So it has some of the same issues that you see with human created code. You will see AI generated code contains errors, bugs, and some of the same reliability and security issues that are prevalent in human developed code. You will also see maintainability issues. When this is a thing which quite folks don't realize. So when you're developing code using AI coding assistants, an application consists of several modules, and it is developed by a team of developers. When you bring all that code together, which is generated by potentially 2 or 3 different AI coding tools, which are unaware of the context, and you bring it together, you stitch it together, the overall resulting code can become very difficult to read, understand, and maintain. And AI often prioritizes syntax and correctness over efficiency, which can lead to churn and complexity, right? And increased technical debt. So be careful of all these four things when you're using and evaluating the tools. Here are some data points to support what I just stated. In fact, GitHub Copilot documentation states clearly that you as a developer are responsible for the code quality and security of the code being generated by GitHub Copilot. They actually recommend you to do rigorous testing, scanning of the code, and checking the code for issues before you deploy it. There are several other studies, and I won't go into all of them, but one of the studies, a university study, looked at, you know, the study was done in Australia, University of Australia. They looked at the quality of 4,000 over 4,000 chat GPT generated codes examples. And these were done in 2 languages, Java and Python. And this was done for about 2,033 tasks. And this study found that 53% of the Java code exhibited code style and maintainability issues. So often when I talk to customers, most customers just think about security of the code, right? And that is top of the mind for everyone, and rightly so. But besides security, you also need to think about maintainability of the code. You also need to think about the other bugs that the code can introduce. So be mindful of those, right? There's another report which came, and this is not related to AI code generation, by the way, but it's related to code, which is pretty shocking, that one single line of C code resulted in $60 million loss for AT&T when they had a bug in a C program. So you have to be very, very careful in terms of the code that is being generated by either the AI or even as a developer, you are writing code. The other example, which is very recent, just happened a couple of months, probably a month back. Air Canada had to offer refund policy for a policy which was invented by an airline chatbot. So AI just hallucinated and invented a crazy policy which was non-existent for Air Canada, and they had to honor that policy. And this resulted in Air Canada having to not only honor the policy, but also withdraw their chatbot, pull it back completely. So hallucinations problem with generative AI is also something which is very real, which you should be thinking about when you adopt AI code generation tools. There's another study which is from GetClear, and this gives you another view as to what you should be thinking about, right? They studied code for the last few years, and they looked at 150 million lines of code that was changed. And then they found that ever since AI coding assistants came into the limelight, people started using them. The amount of churn, or the amount of code which is code which gets reverted or updated in less than 2 weeks, is significantly increasing. It's actually a problem which will lead to for a company spending more time if they don't take look at the churn which is happening because of AI code generation. And it also impacts the code quality. Code is being moved, copy pasted, and there's churn happening, and its churn is happening at a very rapid rate. And again, churn is the percentage of lines that are reverted or updated very quickly after being authored. So that's another issue which you need to watch out for. So how do we address all those and responsibly adopt AI coding solutions, right? So let's talk about Sonar solutions and how we can help you code faster as well as code cleaner. For those of you who are new to Sonar, I'll quickly introduce you to Sonar's products and solutions. At Sonar, our mission is to equip all developers and organizations to write clean code. And clean code is code that is consistent, intentional, adaptable, and responsible. So we have several products and solutions for you to do that, starting with Sonar Lint. Sonar Lint is a free IDE-based plugin that helps developers detect issues in their code real time as they write code. And it can sit right next to Copilot in your IDE and detect issues. Just like a spell checker finds issues in your spelling, Sonar Lint helps you detect bugs and security issues in your code as you write inside the IDE, right? The next one is Sonar Cube. Sonar Cube is a self-managed static code analysis solution from Sonar that helps you, again, make sure that the code that you're pushing out to production is clean, it is consistent, it leads to software that is maintainable, reliable, and secure. So it integrates into your CI/CD pipelines, CI pipeline, and then continuously inspects the code in over 30 languages and helps you write better code. And the last one is Sonar Cloud. Sonar Cloud is a cloud-based alternative to Sonar Cube solution. It also does the same things as Sonar Cube. It sits in the CI, integrates with your CI pipeline, continuous integration pipeline, supports platforms such as GitHub, Bitbucket, Azure DevOps, and a whole lot more. It provides static analysis and helps you find bugs and vulnerabilities and code quality issues that get introduced into your code base. So we support all those. We support over 30 programming languages and frameworks, including infrastructure as a code, and we have over 5,000 rules that help you detect problems. We have a detection engine that is very fast and accurate, and it has low false positives. We help you detect issues like cross-site scripting issues, deserialization issues, injection flaws, or any other security vulnerabilities, right? So we help you do all of that with code which you develop or AI develops, writes for you. So here's how our solution works. Here's a high-level architecture diagram for how things work when you're using coding assistants, right? So I'll explain this here first. So on the left-hand side, you imagine that you have developers in your company using different IDs, whether it's VS Code or IntelliJ IDs or Visual Studio or any of those IDs. So you have your own ID. In your ID, you start writing code, and you have GitHub Copilot or Tab9 or any of the IDE extensions or any of the AI coding assistants. Or if you're using ChatGPT, you add code there in your IDE. This IDE is connected. This IDE has also got Sonar Lint installed in it. Sonar Lint is our IDE extension that I just talked about. So Sonar Lint checks for your code as you type the code in the IDE in real time and helps you detect issues. Once you have written the code, each developer checks in the code into a GitHub code repository, into the main branch or into the test branch or whatever branch you have, right? And that's where Sonar Cube and Sonar Cloud, which are also connected to Sonar Lint, come into play. They look at the pull requests. They look at all the branches that you have, whether it's main branch, test branch, and run an analysis on the entire code base, which was developed by potentially dozens of developers or hundreds of developers, and it comes together, it gets stitched into your main branch. right? So some of the things that Sonar Cube and Sonar Cloud detect are things like advanced taint analysis, deeply hidden bugs, which you cannot easily detect in the IDs, and when you don't have the full context of the branch or full context of the application. So Sonar Cube and Cloud help you clean that code there. And what comes out is basically software that is secure, maintainable, and reliable. We have quality gates in place in Sonar Cube and Cloud that prevent bad code from getting slipped into production, right? So if anytime you detect issue, we tell you what the issue is, how you fix it, and once you fix it, you rescan it, rerun the analysis, and then once your quality gate is greened, you can go ahead and deploy your software into your QA environment or your production environment. So that's how this whole solution works. And we'll take questions towards the end. But if you have any questions, feel free to post them in the Q&A panel, and our moderators will help you answer those. So how do we do it? We have Sonar Cube and Cloud integrated into the continuous integration pipeline. And then Sonar Lint in the IDE ensures that the code which is being generated is clean, it's of high quality, and is secure. Actually, let me go back one more time. So here we have four things in there, right? So we do a complete code analysis in the IDE as well as your branch in GitHub or Bitbucket or whatever Git repository that you're using, or whatever DevOps platform that you're using. We integrate into the CI pipeline. We have a unique clean as you code methodology that helps you develop clean code. One of the things which we are very proud of is less noise, speedy analysis, accurate analysis. We don't want to give you things which are not real bugs or real issues for you to fix in the code. And then we have quality gates, like I mentioned, to prevent bad code from getting released into production or into your QA environments. All right. So this point, I will pass it on to Jeff, who's my esteemed colleague and friend, to give you a demo of everything that I talked about quickly, how it all works. Thanks, Jeff. Over to you.
All right. Thanks, Manish. Okay. So as Manish indicated, one of the things that we'll be showing is the integration of Sonar tools along with an AI-powered chat, like, for example, GitHub Copilot, as you can see here. Before I dive into using GitHub Copilot, one of the things that I also want to emphasize, so I'm using VS Code as my example IDE for today. You can find within the VS Code marketplace for extensions, we're listed, Sonar Lint. You'll find us right here. And once Sonar Lint is installed in the IDE, you'll also find Sonar Lint available in the sidebar on your IDE in other flavors of IDEs. So for example, like JetBrains, IntelliJ, VS Code, Visual Studio, Eclipse, those are the major families that we support. You'll find variations on each IDE has a marketplace. And of course, each IDE has usability conventions as far as how exactly our tools show up. But so one of the things that I want to highlight is, of course, the interaction that we'll see between GitHub Copilot and the IDE, as well as the interplay with Sonar Lint. So I have just the beginning framework of a project that's intended to have some JavaScript code added to it here. There's really nothing that exists yet. So really what this represents is a state where I'm about to add some code. And let's say that one of the things that I want to implement within this project is going to be some kind of web API. So I'd like to use a RESTful web API, and I'm going to pick a subject. Let's say dogs. I love dogs. So let's ask GitHub Copilot to, for example, generate a RESTful API in JavaScript for dogs. And let's say each dog should have a name, a breed, and a date of birth. Great. So GitHub Copilot will go along and think about that. And it's going to give us a nice implementation. We'll see how nice it is. This is looking pretty promising. So it looks like it's decided to use the Express JavaScript framework. There's some other things going on here. I can see some pretty standard RESTful API operations. And it's even going to helpfully explain to us what exactly it is that it generated. This is all great. So if we want to go ahead and try to make use of this code, we can just go ahead and insert this into a new file. And what we'll see here is I'll go ahead and save this, for example, into a file like dogs.js. And so as soon as the file is added into the IDE, now we're going to see some code. And so as an example here, when Sonar Lint interacts with code within an IDE, what's happening here is there's not necessarily a direct integration between Sonar Lint and GitHub Copilot. And in fact, there doesn't need to be. We'll certainly explore in the future whether there are direct integrations that we can put in place that would make what I'm about to show even easier. But even without a direct integration, the really cool thing about these tools is that they're very complementary to each other in the sense that Sonar Lint is going to analyze the contents of the file. Copilot or even ChatGPT or something that you may copy and paste into the IDE is going to add contents into your code buffer. And even without a direct integration, you have the advantage of these tools working complementary together within the IDE and giving you some feedback. So when you interact with code within the IDE, the problems that would be found by Sonar Lint or other static analysis linters that you may have added in your IDE are going to show up down in the problems pane. We don't happen to have any problems because the code, honestly, that's generated by Copilot, when you're specific about what you're looking for, it actually happens to be pretty clean for the most part. So we've got a nice implementation of a RESTful API here. This is great. We do see on the side, Sonar Lint is actually giving us a notification though. So even though there's not any immediate problems, we do also have this other notion within Sonar Lint that we refer to as a security hotspot. And so a security hotspot was raised on this particular code over the fact that the generated code is using the Express framework in JavaScript. That in and of itself is not necessarily, that's not a bad thing. Express is a super popular framework. However, we're just openly, as written, this code would just openly disclose what the framework is that's being used. And so Sonar Lint will, when it raises a hotspot or an actual problem finding in the code, walk you through an understanding of a risk like this, and also give you feedback on what would you do if you wanted to make a modification to the code in order to address it. So like in this particular example, we can take the gist of the suggested compliant solution here and go ahead where we're making use of this framework and go ahead and address that. And so we can see now the security hotspot has gone away, and this is fantastic. So we might also want to continue as a developer working with this. Maybe one of the things that I wanted to add to this implementation of my RESTful API is something like we've gone ahead and given the dogs a date of birth. Maybe we should go ahead and also add some affordance in here to be able to do something like generate the age of a dog. So what we can do when we're interacting with the code, you can ask Copilot to go ahead and generate something. So let's say generate a function to calculate the age of a dog. And let's ask it to go ahead and do that. And what this will actually do, which is pretty cool, is go ahead and generate something. And it's actually gone ahead and added it as an inline method. If we in addition to this, let's say we wanted to do something like take this code out and consider externalizing it into another function. We could do something like function calculate age, it takes a date of birth, and In this particular case, maybe we want to start adding some of the code in here. And so you can see SonarLint, as we start to work with the code that Copilot is giving us some feedback in here. One of the things that we see here is it's actually suggesting that we rename the function. And you might wonder, well, why? Why would it be asking us to do that? Especially it's asking us to rewrite it in terms of a particular regular expression. This is actually an example of enforcing a naming convention on the code, which we saw in response to the poll earlier. A lot of you have an almost equal amount of concern between code security and the maintainability and the standards compliance of the code that's being generated. So this is an example here. It might be an almost silly naming convention, but this is an example of the type of convention that you can enforce with Sonar. And how did the IDE know about this if this is a coding convention that's specific to you? It's through the magic of what we refer to as connected mode. So within SonarLint, you can set up a connection between the Sonar process, SonarLint running within the IDE that's giving you live feedback on the code that you're composing, and in fact, your upstream Sonar server. So whether this is a Sonar Cloud subscription, or you've got a Sonar Cube on-prem or self-managed server that you're using for your teams, you can use that to manage your coding standards. So if you have within your organization defines what we refer to as a quality profile, and maybe you've gone ahead and added on top of what we already have in place as far as the Sonar Way quality profile, you can go ahead and add to your quality profile rules to enforce some of these conventions. So whether it's naming conventions for functions, methods, even trivial things like brace placement, naming for variables, other standards. You'll find within all of our supported languages, if you look for rules that have the tag convention, there are lots of things like this that you can enable. And hopefully for those of you who are already Sonar users, you've gone ahead and enabled those things. Now, when it comes to enforcing a rule like this, what we can actually see is when we look at the code, the IDE's option to generate a quick fix will give us some options here. In many cases, SonarLint has a built-in quick fix. The really cool thing, again, about the interplay through the IDE of these tools is you can even ask Copilot to fix this. And because the description of Sonar's rule is accurate enough, you can in fact have it implement the suggestion of the naming convention for you. So there's a really nice interplay that we see between these tools. I'd like to move on to another example quickly. So, above and beyond this, you might also wonder what would happen if we had some maybe more serious issues that might come along. So a variation on, I was rather specific when we asked for this implementation of a RESTful API. In a previous iteration, I was wondering what would happen if a developer who really kind of didn't know what they were asking for asked Copilot for some questions. And an example here is if I asked it simply to generate some abstract code for a RESTful API, what in fact happened in this particular case is it generated very similar code to my REST API for dogs. But this code was actually so generic that it was doing things like, for lack of any kind of specific object model that we might want to be talking about, like a dog, a person, a customer, it was simply reflecting the body of the request back in the response, which might be a helpful thing to do as you're getting started. If a naive developer actually used the code example like this and tried to extend it into something specific, they could actually wind up getting into a bit of trouble because, in fact, this is a very basic example of a cross-site scripting error. So a cross-site scripting vulnerability, if left in the code, would actually be able to let a potential attacker access the web interface for what this API would result in, and redirect requests to the API to maybe another endpoint where they could then potentially do something malicious. So there's definitely something to watch out for. And if you encounter it, you would hopefully not just get this feedback within the IDE, but you would also see within your project in Sonar Cube or Sonar Cloud, such a thing would result in a quality gate failure. When you have integration with your CI pipelines, as I have an example here for this project in GitHub, you can actually have the pipeline fail based on the quality gate failure, as I've shown in an example here. And I would also like to show that of course, for those of you who are using commercial versions of Sonar, which would be necessary to find the vulnerability in the first place, you can also get nice feedback directly within your pull requests. So if you were interacting with a tool like Copilot, pasting stuff in from ChatGPT, you would get some really great feedback directly within your pull requests that you could also use to act upon. So that was a really quick tour through basically how we see the interaction with AI-generated code. And I would like to hopefully save some of the final minutes to answer some of the questions that you may have. So let's fire away.
Actually, let me wrap it up, Jeff, and then we can take the questions. Thank you so much. Can you see my screen?
Yeah, we've got it.
All right. All right. Thank you, Jeff. Let's talk about the benefits of the solution, right? So using Sonar and coding assistants, you can reduce the risk of the code that is being developed. You can ensure that the code being produced is of high quality and doesn't have any security issues, right? You can accelerate your development lifecycle. You can reduce the time to market. You can increase the developer productivity. So there's lots of benefits. I think the biggest takeaway here is do the right thing, be responsible, right? Adopt AI coding assistants for sure. They help you become productive. But use a solution like Sonar or some code review mechanisms. If it is not automated like Sonar, you should have some code review mechanisms in place to make sure that the code being produced is of high quality and is secure. I will kind of summarize the end-to-end solution here, starting from IDE to the continuous integration pipeline. For any code, whether it's human-generated or AI-generated code, you need to make sure that you have checks and balances in place. You want to make sure it goes through thorough code review. You want to make sure it is, you're removing all the inherent risks that are introduced by AI code generation. And Sonar Lint in IDE, Sonar Cloud, and Sonar Cube in the CI pipeline can play a pivotal role in terms of doing that analysis for you, identifying the issues for you, and even offering fixes for you as you code and create your software, right? So this will help you basically safeguard against any pitfalls, any challenges that you might encounter, and help you build robust, secure, and compliant software solutions if you have checks in place in the IDE and in your CI/CD pipeline. I will end this, my part of the presentation here with a summary here. Basically, you should, do the responsible thing. Using Sonar, we can assure you that we will minimize risk for you. We can reduce the technical debt that gets accumulated and help you derive more value from whatever code however you're producing the code, whether it's AI generated or human generated. We help you do it in a predictable, responsible, and sustainable way with the Sonar solutions. So adopting these coding assistants will give you developer velocity and productivity, but do adopt them responsibly. Trust the code that is being generated by AI, but make sure to review it and verify all code when it comes together in your main branch or in your final application. And I encourage you to try for yourself. Try installing Sonar Lint in your IDE. It's a free extension. You don't have to pay anything. Download Sonar Cube or set up a trial account on Sonar Cloud and explore this. Explore the demo that Jeff just delivered. See for yourself how you can write better code using the Sonar solutions. And here are some additional resources for you to review. We will share the recording with you and the links will be shared in the community post. But if you go to sonarsource.com/learn, you will find a bunch of other articles on this specific topic, which are about, there's a developer's guide in terms of helping you pick up the right tool and looking at what the different factors that you want to think about when adopting AI code development. And with that, I will end my part of the presentation and I will hand it back to my colleague, Kirti, for final comments. Thank you, Kirti.
All right. Thank you, Manish. Thank you, Jeff. That was really great. We have lots and lots of questions also, but we are a little bit over time. So I'll try to at least, make sure that we go through some of them. But before we do that, I just wanted to remind you that our next Clean Code Monthly webinar will be on April 17th. It'll be presented by Peter McKee, our head of DevRel and community, and he's going to be talking about driving DevOps transformation, how to level up your CI/CD pipeline with static code analysis. So you can register for that webinar with the link that's in the chat. And now you'll also see this poll on screen. So if you would like to learn more about our solutions, please do fill it up when you get a chance. All right, so I'm going to gather a couple of questions. We have only a few minutes, but don't worry. We are going to take all of the questions that were posed here at the webinar, and we will do a community post. Our community is also a great place to post any questions that you may have. So I will go through a couple of them. All right. So, Manish, there's one question around the different types of LLM. So you've talked about them here. Victor asks, how do I evaluate the code generation of these different LLMs? If you can, provide some quick input.
Yeah, so that's a good question, Victor. So LLM output is very unstructured, and LLMs by nature are non-deterministic. So it is really hard to evaluate the quality of the code being produced by LLMs. And that is why, exactly why you should have solutions in place to do code review and thorough checks after you evaluate the LLMs. But having said that, there are some benchmarks available out there. There's a benchmark which is commonly used. It is called the Human Eval benchmark. It's basically a data set of about 164 programming problems from the OpenAI. They created this data set, and that's not part of the model, LLM model, which data on which LLM models are trained. So you can use this benchmark to assess the quality of the code being produced. That is one way. There is other coding benchmarks like high school math, grade school math, and other coding benchmarks available. So you can try using them and get some baseline numbers. But I highly recommend using a code review solution, at least for the foreseeable future, till we have a better benchmark in terms of evaluating the LLMs.
All right. Thank you very much. I know we have a lot of questions here, but we are probably reaching the close of this webinar. So we'll be sure to post this in the community. So, and send you an email. So stay on hold for that one. But I want to take the time to, thank you, Manish, thank Jeff, and everybody who attended and this webinar and posted questions. So do visit sonarsource.com for any future information on how to clean as you code, how to use Sonar with the AI assistants, and also check out all the information for our future webinars and events on our website. All right. Thank you, everyone. And we will see you again in another webinar.